So what I'd like to do today is give you a little bit of a perspective on the flood from the City of Calgary's viewpoint. And what I want to share with you are some key learnings. I'm certainly not going to be exhaustive today in trying to cover every aspect of our response or the implications. So when I was thinking of a title for my talk today, I thought you'd probably be interested in what I did last summer. Unfortunately, this is not what I did on my summer vacation. Summer vacation was in short supply after an event of this magnitude. I think it is positive that at least I'm able to start to have a little humor around this event. Certainly as it was going on, the gravity of it, and still today, the gravity of it is something that has profoundly affected the City of Calgary and its administration. So what am I going to talk about? Very brief introduction. You've had a lot of talk, I think, today on the hydrology, the scale, and the nature of the event, but I want to present that from the context of the municipality of City of Calgary. I'm going to talk a little bit about our emergency management organizational structure within the city. This was one of the key elements that led to as favorable a response, if you can call it that, as we were lucky to achieve. I also want to talk about some of the technical tools that we developed before the event and some that were in use during the event. I want to talk a little bit about the management of Glenmore Reservoir, pre-flood reservoir management. A little bit about forecasting and warning, and this dovetails well with what Colleen just presented to you, and talk a little bit about erosion. I'll summarize some learnings and opportunities, and hopefully there'll be a few minutes for some questions. So, our catchments. You've heard a lot about this today. Just to give you some context of how this looks to the City of Calgary, upstream of the City of Calgary, we've got almost 10,000 square kilometers of drainage area, most of which is mountain catchment, so highly productive, higher elevation, greater precipitation, much more rapid runoff response. We have very limited natural or constructed storage, and I'm sure that is an element that's come out in some of the other talks today. And all of that leads to a very flashy system. We just talked about the event a little bit. We had areas in the mountains that received up to 325 millimeters of rainfall. Wow, that's as much as we get in the City of Calgary in an entire year. That occurred over 2 days. So we had a foot of rainfall in some of the most productive catchment. And our catchments very much are dominated by this mountain response. Another important sociological aspect, something that has become somewhat embedded in the culture and something that our organization has to work against, is the fact that there has been a long period where we have not had very significant events. So we know as hydrologists that this type of catchment can produce very powerful floods. We just haven't seen them for a long time. And I also want to add a bit of context. This is what Calgary looked like in 1910. So I know there was a discussion this morning about watershed planning, and my friend Andy took a shot at me as I came up here about me living close to the floodplain. But look at Calgary, and this is not a very different picture from many of the other settled areas within Alberta or throughout the world. Very often water supply is a very important element to the siting of municipalities. By 1910, you already had a concentration of development within the most flood-prone areas that was quite significant. So not 2 decades after really Calgary was basically a campground, you already had significant intensification, urban use in the areas that have the highest risk. So there has been a long history of development, there has been a long history of human use in these areas that are most impacted by flooding. Colleen just put up some mapping, gave much more detailed information, but again, look at the bullseye here. It's really the upper part of the Ebow catchment, the Highwood catchment, and the middle part of the Ebow that got peppered, that really took the bullseye of this event. And again, across 2 days, 325 millimeters. Yeah, we're getting out there in terms of return period. The hydrographs that we've been able to resolve on the Bow River, and I present this with the big disclaimer, preliminary and for discussion, because the City of Calgary is not the archival authority responsible for publishing information after an event. All I'm presenting here is the information that we were able to collect, and this information was relatively well verified in that during the event, in addition to all the work that AESRD was doing, we retained the services of some consultants to go out and actually do some physical measurements off bridges during the event. So we're quite confident on the Bow River of what we saw, and we saw, again, a very rapid rise within about 12 hours, going from more or less normal summer flows all the way up to flow magnitudes above the Ebow River of over 1,700 cubic meters per second and below the Ebow River of over 2,400 cubic meters per second. So very much getting out into the 1% annual exceedance probability range. Very rapid, very extreme event. Story is even more dramatic on the Ebow River. On the Ebow River, not having the buffering of the larger catchment area and the attenuation of the transalta structures, what we saw coming into Glenmore Reservoir was very peaky. So peaky, in fact, that we would not have expected the level of reduction that we saw in peak flow on the reservoir, because a normal design hydrograph would have been much wider. You would never, as a hydrologist, have expected that you could have this near vertical rise on the hydrograph limb, that blue hydrograph you see. Absolutely incredible response for a very short time frame. And I'll spend a little bit more time talking about this later, but that peak came up and basically filled Glenmore Reservoir from about 4 meters below crest, the lowest we can draw Glenmore, and still maintain water supply to our intakes. Filled that reservoir up within the span of about 6 hours. Had Glenmore not been as low, this peak would have traveled, or a portion of it may have traveled through downtown, resulting in levels up to 2.4 meters higher than what we actually did see. And again, normally one would not have expected this level of attenuation, because a typical design hydrograph is much wider in base, much more slowly rising. By the time the peak would arrive, the reservoir would be full and the attenuation capacity would be largely used up. And again, the context in terms of the historical and social aspects, this is a graph. Don't worry about trying to read all the numbers on this. These are the annual peaks on the Bow River lined up, and I think Dr. Ryan this morning had a similar chart. This shows that really prior to the 2013 event, well, we had 2005 on the Bow, but 2005 is a stubby little guy down here, not terribly large. Certainly above the stability threshold for some of the bed and bank materials in the Bow River, but nothing like the magnitudes of flow that we have seen or have been resolved from either anecdotal or systematic records on the Bow River. So you've had this period of multiple generations, literally 60, 70 years, where you really have not had much of a significant event on either of these rivers. There are lots of theories floating around as to why, but certainly that has had an impact of leading people within the municipality to maybe not be as cognizant of this risk as it actually is. Very similar record on the Ebow River. On the Ebow River in 1932, interestingly, that was the year that Glenmore Reservoir was built. It was sitting there bone dry, empty, just after construction. Someone's got a lot better luck than I, because the reservoir actually filled up and produced a flow bigger than the 2005 event. But thankfully, the reservoir was there and was not still under construction at that time. So again, there have been significant events in the past, but not for quite some time. What are the things that did work? One really important aspect of the emergency management and the overall response to the flood was the fact that the City of Calgary has organizational structures put in place so that we can respond to events of this nature. Not just events of this nature, but all types of emergencies. And this structure was absolutely critical to having everyone in their specialties, everyone in their business units understand and know what they could do, who they would communicate with, and how they would communicate. And really have an entire hierarchy of emergency response going on, things occurring at the federal level, at the provincial level, at the municipal level, and largely that is driven by CEMA, Calgary Emergency Management Agency, which acts like an umbrella and pulls together all the business units and municipal partners, people like the zoo, NMAX, various utility providers, and a whole series of business units within the city to get together and make decisions about how to most accurately, most quickly, and best respond. Now, within the water business units that I'm a part of, we actually have our own dedicated team that looks at emergency management, planning, and response. That group is called Business Continuity and Emergency Management, and it is their mandate to look specifically at water-related emergencies, be they related to water quality, water supply, a main break, ice event. The team that I work with is, for lack of a better term, we're the river geeks. I don't know how well you can see this on the slide. But we provide that technical information, and for lack of a better term, we're known as the river geeks within the City of Calgary. So our job is to supply all of that technical information, run the models, prepare inundation mapping, interpret some of the engineering aspects, some of the structural aspects, erosion-related aspects that come with events of this nature. So the organizational structure ultimately clarifies the ownership of issues. Who is the author of our flood emergency manual? Who has control over which components of response? Having all that laid out beforehand makes for much more rapid and efficient communication during the actual event. And these relationships ultimately, like I say, are the foundation of having the possibility of having a very quick and efficient response. And all of this structure actually allows the specialists to focus on what the specialists are special at. That is, it allows me to do my river engineering geek stuff while SEMA and other agencies are out there affecting the responses that we've thought about and put in place or are able to comment on. So again, there are numerous stakeholders involved, and I'm very pleased to see Colleen Walford's presentation here today. The City of Calgary absolutely applauds and is grateful for the input of teams like the team that Colleen works for. We work closely with the forecasting folks at Alberta Environment and with other stakeholders like TransAlta Utilities to make sure we're getting the best information about what might be happening within our jurisdiction at some point in time. We then feed that information to our water business emergency management experts, and then they interface largely with Calgary Emergency Management and our EOC. So we're quite unique, again, in that we have a team within water dedicated to emergency management, and that makes for a much more efficient response and spreading out of information throughout our 15,000 strong organization. Technical tools. Since in some ways the 2005 event for the City of Calgary was a bit of a blessing. It was a little bit of smelling salts underneath that 70 years of record where we hadn't had a significant event. Without that event, I'm not sure that I would have been able to leverage the internal forces within the city to be able to generate some of the technical tools that were so important to our response. So one of the key things that we did, and again I'm going to call out some props to Alberta Environment and Sustainable Resource Development, because they supported us and we were able to develop before the event new models and mapping. In 2010 through 2012, we worked closely with the province and developed a new set of inundation maps and models. We had information from 05, from the 05 event, that our models and maps were a little bit out of calibration. I mean, really, they were amazingly accurate for the time and the vintage and the amount of change that had occurred. It was amazing that they were as accurate as they were. But we felt we needed absolutely the best possible tools to be able to base our emergency management upon, and Alberta Environment supported us on that. So in 2012, we were able to prepare a new set of inundation maps and models, and those really became the technical underpinning, the geek foundation, if you will, of all of the actions that are embedded in our emergency management, our flood emergency manual. We're also able to share that mapping and information with other agencies like SEMA, who are able to use that in a graphical sense and understand where impacts might be and make for a very good platform to make more efficient decisions. We also work closely with ASRD in terms of getting better forecasting information. They gave us direct access to their WSKI database that Colleen was talking about earlier, and they provide us with runs from their SAR model very efficiently. So we have an efficient way of transferring that information, being able to talk about what kinds of hydrographs we think might get generated from conditions we're seeing, and for us to actually, within the city, be able to have another level of nuance and understand what might be happening out in the catchment. We have also developed new tools in the last 4 or 5 years around reservoir routing for Glenmore. So when, as the owner and operator of Glenmore Reservoir, the city is responsible to make sure that we're doing all we can to affect the balance of water management initiatives that we have. We definitely have to continue supplying drinkable water out of that plant. We also have to look at the environment. We also have to look at flood control. We also have to look at recreational use and a whole host of other municipal and infrastructure related impacts. But we've developed some new tools since 05 that allow us to do that a little more quickly. So we can scenario up, when I get a hydrograph from Colleen and her team, we can scenario up very quickly and understand what the implications of various control strategies might be, and that allows us to make more cognizant decisions about where we're going. We've also spent a little bit of time and a little bit of effort improving the amount and number of sensors that we have through the city. Like any forecasting or monitoring group, we're absolutely flying blind when our controls go down. So we've tried to backstop that by putting in some cameras, putting in some really low-level technology, staff gauges on bridges, and we will literally send people out. If we don't have a camera nearby, we'll literally send people out to get real-time levels, send those back so that we can interpret what's happening in the case that any or all of our hydrometric monitoring stations have been damaged by high flows. And all this has been supported by our information technology people who make all of the data transfer and all the software and all the systems available to us, and that's not insignificant. This is a quick screenshot of what our mapping looks like. So we have mapped multiple return periods going from about the 10-year event all the way up to the 100-year event. And then this, again, formed the basis of all of the information, all the responses planned in our flood emergency manual. What about reservoir management? Well, Glenmore is not a very big reservoir. It was built in 1932, as I mentioned earlier, primarily for water supply. It's really a little embankment across a fairly narrow river valley. It's got about 7 meters of active storage. We draw it down about 4 meters from the crest, the concrete crest you see in the photos there. And in a big flood, it might overcrest or spill over by 2 to 3 meters. That's really all the storage you've got. When you've got 1,200 square kilometers of mountain catchment upstream, you're really not in a position where you've got enough storage here to do much. What we know from various simulations with the tool I mentioned earlier is that any event bigger than about the 1 in 20-year event will likely come over Glenmore with relatively modest attenuation. Anything bigger than about the 20, we lose control. We can't do a whole lot more. Again, given that typical design-shaped hydrograph. So again, think back to the hydrograph I showed you earlier. With a really sharp spike, we can have a very measurable impact on the peak. But for a more typical hydrograph, anything bigger than about the 1 in 20, we're largely out of business. We do regularly review and upgrade the operating rules for Glenmore. Again, I'll show you this hydrograph I showed you earlier. What you see in the way of the difference on the rising limb between the blue line, the inflow hydrograph to Glenmore, and the red line, the outflow hydrograph to Glenmore, that skinny little wedge, that's the storage of Glenmore Reservoir. That fits underneath this curve about 5 to 6 times. So really what this graph tells you in a very simplistic way is that, wow, holy smokes, the 2013 event was gigantic. The peak was off the map. But in order to really affect any impact on the peak, you'd need about 4 more Glenmores, generally. Now, you see the rest of this hydrograph looks largely like a design 1 in 100-year hydrograph. In and around 700 cubic meters per second is about the 1% chance return period event. And you can see it's coming through largely unattenuated. The inflow and the outflow are almost equal after Glenmore filled up. So thankfully, the spike here happened at the beginning of the event when the reservoir was low and happened, right at the beginning. Had it happened a little bit later, it would have come through Glenmore virtually unattenuated, and like I say, elevations through downtown and through, the entire lower Ebow would have been up to 2.4 meters higher. Forecasting and warning. One of the other presenters this morning, here's a quick quote. Yeah, the snowpacks weren't really that wild. Snow typically not that big a driver. The process of snowmelt is generally a lot slower. When you have rain on snow, of course, it comes off much more quickly. But really, forecasts even 4 or 5 days before the event were not looking terribly nasty. I mean, we looked like we were getting into maybe a fight as big as the 2005 event. Now, 2005 on the Bow River, just to clarify, was only about 1 in 10-year return period. We had some impacts, but they were relatively modest. The damage curves for both the Bow and the Ebow get quite steep in and around the 10 and 20-year event. So when you start getting up above the 20-year event, you start to see much more widespread impact. So at the 3 to 4 days before the event, there really wasn't expectation that this event would materialize into something as significant as it ended up being. As Colleen mentioned, we were largely expecting about 100 millimeters, maybe 150, 200 under some smaller local convective cells that would form inside this bigger cold low. Initially, we were expecting the bullseye to be well north. We were expecting it up in the Red Deer, maybe even further north than that. So we were certainly watching this system, but there wasn't reason to expect that the Ebow and Bow would be the target, even a couple days before the event. The event did stall out, though, over, as you saw from the preset mapping, over the Ebow, Highwood, and sort of central part of the Bow system. We saw that typical counterclockwise circulation, and this was a little bit warmer than normal cold low. Normally I am hoping for temperatures that above 1900 meters, 1800 meters, that are at or below zero so that we get that as snow, and at least that component of the catchment isn't also contributing. In this case, we did see much of the snow come off. And the speed of the response is really the piece that hydrologically speaking is the most interesting to me. The event hydrograph that I had there, the inflow to Glenmore, I've tried to compare that with design hydrographs we had from previous studies. And you can see that the rate of rise here, the steepness of this curve, is just not even comparable to what we would have expected for a 1 in 100 or a 1 in 200 year design event. So very, very rapid response. In general, about twice as fast responding as any events we've seen in the record in the past. And that's a lot of I think that's a lot of the story, not only for Calgary, but for other municipalities. The sheer speed of the response in this case made it very, very difficult. Under the best of times, within the Ebow Basin, we've got maybe a 10 to 12 hour time of concentration and maybe 8 hours of transit time between Bragg Creek and the city. And with this event, so normally you're talking about half a day to effect essentially evacuation of a significant part of a very densely developed major metropolitan center. Here we're talking about half that. So there really wasn't as much time to implement many of the responses that are embedded in our flood emergency manual as we would have liked. That required us to think about a number of things, not least of which is prioritization. Of course, all the items in our flood emergency manual were prioritized, but we had always conceptualized that had we had an event of this nature, that there'd be at least a little more time. And I know we're only talking hours, but that in itself is significant when we're talking in a frame of 12 hours for an overall response. And one aspect that I'm relatively pleased with about the overall response is that given the massive population and usership that we have in our high-risk areas within the city, within the floodway and flood fringe within the city, we were still able to communicate effectively enough to get people out, to get the areas evacuated and protect safety. Obviously, within our hierarchy, safety trumps all of the other values. Economic loss is important, public infrastructure is important, but safety is absolutely the #1 goal of all of the work that we are trying to do. Evacuation still completed in time, to me, is a win. Erosion. Well, if there are any morphologists or erosion people in the room, you know that generally stability for most bed and bank materials on most rivers, well, you're into maybe 1 in 2 to 1 in 5 where things start to really move. When you go into 1 in 100, we had places where we had velocities of 5, 6, 7 meters per second. Extreme downcutting. This happens to be the LRT at McLeod Trail just by Earlton. In many locations we had erosion that cut all the way to bedrock. So there were places where standing on the bank of the Ebow River, or pardon me, the Bow River, now the Thalweg, the lowest part of the channel, is 50 feet below, 15 meters below where you're standing, where before the event it might have been 5 or 6. Very significant. And we lost in places up to 60 meters of lateral width, over 100 meters of reach length. So literally, width of a football field disappeared more or less in a few hours for a span of up to 500-600 meters. This is the south part of Inglewood, immediately south of the Cushing Bridge that carries 17th Avenue over the Bow River. And you can see here the types of effects that we were dealing with. Half the road disappeared, and there's a water line in that road. Obviously, those residents would have ultimately become impacted potentially had nothing been done. Like I said, velocities of up to 7 meters per second, scour down 6-7 meters in places, grabbing all the way to bedrock. This is what that same site looks like in section. And you can see from this photo, maybe this is not the most flattering photo from the City of Calgary standpoint, in that we had to use everything that we had available. I was coming in on shift I was covering the night shift, and as I was coming in around 8 o'clock, I saw a boom truck loading up Jersey barriers from the parkade at the water center, the building where I work. And I thought, oh, that's not a good sign. I hope they're using those for traffic control and not for what I thought they were using them for, which was to build spurs. And sure enough, we were using them to build spurs. We could not get enough riprap mobilized quickly enough. We had to throw everything we had in to basically arrest the erosion. Another site, this is the Home Road site. If you're familiar with the Shoaldice Bridge that carries you into Bowness from the east, we had very significant erosion there. A church and about 13 private residences were threatened by erosion. Again, multiple Olympic swimming pools worth of dirt basically disappearing off on their way to Saskatchewan in, in a matter of hours. So the city had done some pre-work on this. We had some idea of what to expect because we had done some cataloging work in 2010 that looked at where are our vulnerabilities in terms of erosion. And during the event, we actually engaged consultants. We were so busy dealing with the event itself that we engaged the consulting community and got them involved in helping us with the designs and direction of contractors at sites. So how do you build spurs? Where do you do this? And that was also quite useful. But material supply, like I showed you on the previous slide, really was one of the big issues. Making sure that we have enough stockpile of material to be ready for an event of this nature is one of the key learnings from the overall event. So quickly, just to summarize some of the learnings. Organizational structure. The city had a great organizational structure, and I really saw benefits in how information flowed once the event got going. These organizations within the broader corporation of the City of Calgary do training, we do exercises each year, and having this kind of structure to gravitate to an event when everything's exploding all at once absolutely made the difference between a fairly effective response versus a much more harried response. Technical tools. With partners like Alberta Environment Sustainable Resource Development, the city was able to have some tools that really helped us understand what might happen. So we had maps that didn't look too different from what ended up happening on the ground that really informed our response. And wow, the event hydrology, if there's one thing I take away from this event is I've made some new learnings about Glenmore. I've made some new learnings about what kinds of hydrographs can come into our system, and the speed of response really leads the City of Calgary to recognize that anything we can put in place that's permanent, that doesn't rely on operations during an event, obviously comes at a high premium. The Glenmore Reservoir, holy smokes, a lot more useful than I would have thought. Again, potentially up to 2.5 meters of water level differential that it created. And traditionally, you wouldn't have expected that level of attenuation for this kind of an event. And in terms of erosion, we do have to prepare more and better. Certainly don't want to be running out of materials, and we certainly need to look at having pre-can designs so we can get out on sites as quickly as the events are happening and things are unfolding to be able to arrest that.
You talked about new inundation maps, and how do those ones that you developed relate to the ones that have been developed by the Canada Provincial Flood Program?
There are multiple uses for maps, and the City of Calgary has many business needs that require understanding of applied hydrology and hydraulics. So we're constantly building and developing and interpreting new models and maps. Most people are familiar with the land use maps, the maps that are used for floodway and flood fringe designation. Those are very important because they identify, if you will, for lack of a better analogy, the speed limit in terms of what is allowable in terms of development, land development. Those maps have a different purpose, really, than the maps that we've been talking about, though the two are interrelated in that they both relate ultimately back to the applied hydrology and hydraulics. So the maps that are embedded in the land use bylaw and within the provincial flood damage program, they are available online, they've been available. And one of the nuances here is the city's very cautious about, as is the province, I believe, about releasing multiple sets of maps because to the casual user, we absolutely do not want them confusing the land use or regulatory map, the speed limit, if you will, with the more technical tools that we use to inform a whole bunch of other business needs, like emergency management. So the two obviously bear a correspondence in that they're both trying to describe the hydrology of the Bow and the Ebow rivers, but one is a regulatory map that really has to do with policy. The other informs a whole host of other things. Of course, there will be considerations in terms of as time moves on and rivers change and hydrology changes, there is always a question of what do we do to reflect the level of risk. For the time being, in terms of land use policy within the City of Calgary, it is the land use bylaw maps that most people will be interested in because those set the regulatory limits for development.
I guess my question is, I know that hindsight's 20/20, but if you had you known that you had 200 plus millimeters of rainfall in the mountains, what would you have done differently, and how would that have possibly aided in mitigating some of the disaster impacts?
Oh, it depends how early we knew. I mean, certainly if we knew early enough to put all of the flood defenses that we have embedded in our flood emergency manual in place, we would have built them all. And we do that. Like I said earlier, because there has been a long period where we have not seen big events, we've actually put out, and many people wouldn't know this because they're much more local, but we have put out flood protection barriers and gone to sort of partial response modes for smaller events, 2008, 2011, 2012. Now, had we known what was coming, we would have put all of our emergency response measures in place. We got not all the way through the list because of the speed of the response. So what we would have done is enacted all of our plan instead of having to prioritize and only cut off the top, if you will, of the most impactful responses.